Okay, so in this um, section, we're going to talk about derivatives. And derivatives are the average rate of change. Um, for y is equal to f of x, the average rate of change from x equals a to x equals a plus h is this. Now, this denominator part, if we have a plus h minus a, well, the a's will cancel and you're left with the h. This is more commonly what you'll see. And a lot of times you actually see it with the x's instead of the a's. But this is basically your average rate of change that you learned in the college algebra, or it's which is also similar to the slope formula, right? This would be um, the same thing as f of x sub 2 minus f of x over x sub 2 minus x, because we know f of x is the same thing as y. Now, the numerator and denominator are differences, so it's actually called the difference quotient, which is what you learned it as in college algebra. Now, instantaneous rate of change for y equals f of x, the instantaneous rate of change or rate of change at x equal to a is this. So the instantaneous rate is where we're going to do the limit. So the limit as h approaches 0, if that limit exists. We also have the slope of a graph and tangent line. So given y is equal to f of x, the slope of the graph at point a, comma, the function at point A is given by this. So, you're going to notice that those are basically the same thing. Is provided this limit exists, and in this case, the tangent line to the graph is the line through that point with the slope given by the limit. So the derivative is y is equal to f of x, and it's going to be denoted as this f with the little, like a little apostrophe, but not quite an apostrophe. It's f prime of x. That is going to be, it's like a little flash there, uh, is what the derivative will look like. You can also use just a y in that same little mark, and that's going to be equal. Oh, here you're going to see it with x's, right? X's, a's, it's the same formula. We're just, hey, we're looking at f of x in that x, if that limit exists. And then here's our derivative exists for each x in the open interval when f is said to be differentiable over a and b. So for differentiation, the process of finding the derivative of a function. So summary interpretations of the derivative is the derivative of a function. F is a new function. The domain of this new function, or the derivative, or f prime, is a subset of the domain of f. The derivative was or has various applications and interpretations, including the following. We have the slope of the tangent line for each x in the domain of that derivative. That f prime function is the slope of the line tangent to the graph of f at the point x, f of x. And then, oops, wrong, we're going over here. Instantaneous rate of change for each x in the domain of f prime is the instantaneous rate of change where y is equal to f of x with respect to x. And then we also use it for velocity. If f of x is the position of a moving object at the time, then v, the velocity, is equal to that derivative of our f of x function, is the velocity of the object at the time. Now, to find a derivative, there are 4 steps. You can do them all at once, but we're going to do it in the 4-step process, so it doesn't seem as much because sometimes it's going to get a little messy. So first we'll find our f of x plus h, then we'll find our f of x plus h and subtract the original function of f of x. Then we're going to put that all over h, and then if we need to find that limit, we're going to do that. And then the new function, so this is where you would have learned through college algebra, and now we're adding that limit step. So the new function, f prime, is a new function derived from the function of f. Therefore, it's a derivation. All right, so let's go look at our first example. We have a revenue analysis. The revenue in dollars, because this is for a business math class, so there are going to be more business math related questions versus just calculus. The revenue in dollars from the sale of some plastic planter boxes is given by this, and that X determines how many planters we are creating. So we are looking at uh, what is the change in revenue production, and then we've got some other things that we're going to look at. So I'll put those out there each time we're going to look at what's next. All right, so the first thing I'm going to do, we are looking at 9.4 is the section in the textbook that we are using. So for example 1, we're looking at r of x is equal to 20x minus 0.02x squared. And there are some stipulations put into us that we have non-negative because you can't make a negative number of planters, and that's what our x is referring to. So it's going to be a positive number, and it's capping out at 1,000. All right, so the first thing they're asking us is part A, is we want to know what is the change in revenue if production is changed from 100 to 400 planters. Well, this would be our revenue function from x sub 2 to x sub 1. So what's the difference? So we're just doing the change, not the rate of change on this. And the two values that we were given are 400 and 100. So this would be r at 400 minus r of 100 is what we're looking at. Now, what I like to do is work that separately and then bring it back in. So we're going to have our r at 400 we're going to find, and we're also going to find the r at 100. We're going to use our function. So we have 20 times 400 minus 0.02 times 400 squared. And I'm just going to put that in the calculator. We could do it a little bit, but that decimal is going to make it a little bit harder. But you can just put it in your calculator. So we're going to get 4,800. And then we're going to do it at 100 as well. Same formula. We're just plugging in 100 instead of 400. So that will get us 1,800. All right. Now what we can do is take these two values right here, and we're going to plug them in right here. So r at 400 is 4,800. And then we're going to subtract out the r at 100, which is 1,800. And that gets us a total of 3,000. That's our revenue change from making 100 planters to 400 planters. So what does this mean? So what this means is that as we are increasing our production from 100 to 400 planters, the increase in revenue will be $3,000. All right, let's go look at part B. So for part B, it says, what is the average rate of change in revenue for this change in production? So what's the average rate of change in the revenue? Okay, so that average rate of change that we are looking at, we need to find the average rate of change in revenue. So that's going to be our change in revenue divided by the change in production. Something that we know, basically, what we were talking about at the very beginning, is instead of it being like f of x, because we're using revenue, it's r of x sub 2 minus r at x sub 1 over x sub 2 minus x sub 1. Well, this is just like our slope formula, right? And this is coming from part A. So we've already found this part right here. We just located that. So now we are going to do some math here. So that's going to get us r at 400 minus the r at 100 over 400 minus 100, because that's our change in our planters. Now we already have those values, so I'm just going to pull them from what we just did. So we have our 4,800 minus 1,800 over 4 minus 1 would be 300. And you could have just pulled the 3,000 down, but I want to make sure you understand where all of our numbers are coming from. So that's going to get us 3,000 over 300, and that will equal 10. So what does that mean? The average rate of change in our revenue is $10 a planter when the production is increased from 100 to 400 planters. So this is our increase. As we increase in that, that's what our average rate of change in the revenue is also going to increase. All right, let's go look at part C. So C, what is the instantaneous rate of change of revenue of 400 planters? So now we're looking at that instantaneous. So now we need to do that 4-step process to find that. And we have where we're going to also do that limit. All right, so we're going to find the instantaneous rate of change at 400 planters. All right, so this is where we're going to do that limit as h is approaching 0 of our f of x plus h minus f of x all over h. All right, so the first step we need to do, we want to find the f of x plus h. So I'm going to step this out in that 4-step process, just like I talked about. So our revenue function, that's our function that we're using. So let me write that up here. We're still using our 20x minus 0.02 x squared. That is our r of x, that is our function. Okay. So we're going to have 20 times our x plus h minus our 0.02 times our x plus h squared. So over here, I'm going to make a little side note of some math because we're going to use this a couple of times throughout this. We need to square that. And I like to do that part off to the side rather than in it because it gets a little boggy with all the math already. So if we look at x plus h squared, that's the same thing as x plus h times x plus h. So if I multiply this out, I'm going to get x times x and x times h. So x times x will get us x squared, x times h. And then in the second half, we get h times x and h times h. So we end up with those 4 terms. Well, these two are going to combine, so it gets us x squared plus 2xh plus h squared. So I like to do this part over here so I don't have to do it in the midst of my problem. All right, so we're going to distribute our 20. So that'll get us 20x plus 20h. And then this will be minus 0.02 times this part that we just found over here. So x squared plus 2xh plus h squared. So let's distribute that. So that'll get us 20x plus 20h minus 0.02 x squared. And then 0.02 times 2 will get us, and it'll be negative because we're going to distribute the negative, negative 0.04 xh. Oh, we're going to run a little bit out of space, so sorry. Minus 0.02 h squared. So sorry, I got a little too big in my side note. Just kind of bulk that off a little. It'll be all right because we're going to rate some more. Adjust my camera slightly. All right. So now we've got that first part. Now we're going to go on to part 2. Okay, so the second part is going to be our f of x plus h minus the f of x. Well, this part here is our f of x plus h. So let's switch colors. So we're going to have our 20x plus 20h minus 0.02x squared minus 0.04xh minus 0.02h squared. And then from that, we are going to subtract our original function, which will be our 20x minus 0.02x squared. So now we got to do a little bit to distribute that negative. So I'm going to scooch over just a little bit. So we have 20x plus 20h minus 0.02x squared minus 0.04xh negative 0.02h squared. And then a negative times 20x is minus 20x. And a negative times a negative will get us positive 0.02x squared. Now on this, what should happen is the terms that are x's only, or x squares only, no h's, should cancel out. So you'll notice that we have a 20x and a negative 20x, and we have a 0.02x squared and a positive 1. So the terms that we're left with all have h's. So this will leave us with 20h minus 0.04xh minus 0.02h squared. So these 1, 2, 3 terms. So that is that part. Now we're going to go do our next part. We'll do step 3. All right, so for step 3, this is where we're going to take our f of x plus h minus our f of x and put it all over h. So we already know what that looks like on the top. So this is going to just bring our 20h part here down. So 20h minus 0.04xh minus 0.02h squared. And now it is all over h. So what we need to do is simplify where we can. We do have terms that all have h's, so we can factor out an h on the top. So we have 20 minus 0.04x minus 0.02h all over h. That will cancel out the h's. And we are left with 20 minus 0.04x minus 0.02h. And I should be boxing these. So sorry. Let me go back and box a little bit, just so you can see where that final part was. That way you know those are the parts I was grabbing. They're not our complete answers, but they were the answers for those parts. Okay, so now we have a step 4. And for step 4, we are looking at the limit as h approaches 0 of our f of x plus h minus f of x all over h. So what does that mean? That means we have the limit as h approaches 0. This is this part right here. So we have our 20 minus 0.04x minus 0.02h as h approaches 0. Now, this will also be known as that little thing. So this is going to be that r prime of x. And as h approaches 0, well, now we've learned a little bit about limits already. So we're bringing in our prior knowledge. That means h is getting really, 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 really small as it approaches 0. So as things get really, 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 really small, they are going to, for the h, it is going to get smaller and smaller and smaller, and it goes towards 0, which is what that limit means. So we'll still have our 20, and we'll still have our negative 0.04x, but this part here, this is going to get really, really small. So it's going to go to 0. And this would be what we were looking for part C, which was the instantaneous rate of change of revenue of the 400 planters. Now, what it asks us to do is to find that. Now we found that part, right? We found the derivative. Now what we need to do is actually find the value. So we're looking for the value of our function at 400. We already found this. This was part A. We found that we had R at 400 was equal to 4,800. And we also found, now that we have found this, what we're going to do is find our derivative at 400, our instantaneous rate of change, which will be 20 minus, 0.04 times 400. Again, you can put that in the calculator if you wish. We can kind of do the math on this, but we'll just pop it in a calculator for now, and that gets us 4. So we have two values here that the instantaneous rate of change is 4. So what does that mean? That means that the production at 400 planters, the revenue is the $4,800, right? These are dollars. And they are increasing at a rate of $4 per planter. So as it's increasing, that's the instantaneous rate of change. They're going up by $4 a planter. And we do have a graph to look at for this problem. This kind of shows where some of those points are. At 400 planters, we have a price of 4,800. At 100 planters, we had 1,800. So that gives us some points to plot. And you can kind of see how the production is happening as we're going. And then this is your average rate of change that is happening. All right. And those were also the numbers we saw in our problem. Okay, so let's go look at problem 2. We're going to just find some derivatives. So we're not necessarily going to do all of the long steps, but we are going to do some throughout our entire time with derivatives. But we're going to do some so you understand how those work. All right, so for example 2, we want to find the derivative. And it looks like we're only doing f of x's, so basically that is going to be what that looks like. So let's go for A. So for part A, we have f of x equals -5. Now, just to recall, we are using that our f prime of x is equal to the limit as h is approaching 0 of our f of x plus h minus f of x all over h. All right, let's go to it. What's the first thing that we notice? We notice there's no x here. So this problem's going to go really fast, but it's good for you to recognize that. Now we could look at, there's always an x to the 0 power there, which equals 1, and that's why it just won't be there, but we're all good. So step 1, we're going to find our f of x plus h. Well, there's no x there, is there? So that means it's just going to be -5. All right, step 2, we have f of x plus h minus our f of x. Okay, well, our f of x plus h is -5, and then we're going to subtract our original function. Our original function is -5. Simplify this up, we end up with -5 plus 5, which equals 0. That's the equal part for each of those steps. And then let's go to step 3. We have f of x plus h minus f of x all over h. Well, this will get us 0 over h, and 0 divided by anything, no matter what that value is is going to still be 0. And then on step 4, we have the f prime of x is equal to the limit, as h is approaching 0, of our f of x plus h minus f of x all over h. Well, that means we have the limit as h is approaching 0 of 0. Well, that's just going to be 0. So 0 is our derivative for that, and that will be for any constant. Any constant, the derivative of a constant is going to be 0. Okay, let's go to our next problem. So this will be part B. So B is going to be f of x equals 3x minus 7. So step 1, we want to do f of x plus h minus just f of x plus h. Sorry, getting ahead of myself. All right, so this time we actually have an x, so yay. We could do a little bit more math. We're going to have 3 instead of x. We'll have our x plus h, and then minus 7. So that'll get us 3x plus 3h minus 7 when we distribute. So this is the part that equals that. Step 2 will be our f of x plus h minus our f of x. So this will be equal to our 3x plus 3h minus 7 minus our function of 3x minus 7. So this will be 3x plus 3h minus 7, and then negative 3x. Negative times a negative is positive 7. And again, like we talked about, some of these are going to cancel. Our positive 3x and our negative 3x, and our negative 7 and our positive 7. Those will cancel out. That will leave us with 3h, and that's it, because everything else has canceled. All right, let's go to step 3. Step 3 will be our f of x plus h minus our f of x all over h. So that is going to equal the part we had here. We have 3h divided by h will just get us 3. Okay. Step 4 is the f prime part is equal to the limit as h approaches 0 of that f of x plus h minus f of x over h. So this for us will be the, let's do the other color. I'm trying to not have it all blend together in the same color. All right, so this will equal the limit as h approaches 0. What we have left from this was just 3, and there is no h, so it's just going to be 3. So that would be our derivative. All right, let's go do C. So for C, our problem is 4x minus x squared. Oop, I forgot my f of x, so let me rewrite that. So sorry. So we have f of x equals 4x minus x squared. And I know I could have written it on the other side, but I like to have it in that order just so as we're processing the stuff, it looks the same. All right, so first up, f of x plus h. So that's going to be 4 times x plus h minus our x plus h squared. Now, do you remember on the first problem we had that side note where we have x plus h squared going to be the same answer. So I'm just going to pop this in there rather than rewrite it. So this will get us 4x plus 4h minus our x squared plus 2xh plus h squared. As long as it's still the same thing in there, that's always going to be that answer. All right, let's distribute our negative. We get 4x plus 4h minus x squared minus 2xh minus h squared. All right, that's the part for this one. Let's go do step 2. This will be our f of x plus h minus our f of x. So that's going to get us our f of x plus h. So 4x plus 4h minus x squared minus 2xh minus h squared minus our original function of 4x minus x squared. Let's distribute that negative. We get 4x plus 4h minus x squared minus 2xh minus h squared minus 4x plus x squared, because again, a negative times a negative will get us a positive. And those are going to do some canceling again. We have positive 4, negative 4, a negative x squared, and a positive x squared. So that leaves us with our 4h minus 2xh minus h squared for this portion. And then we have another step to put that all over h. So we have f of x plus h minus f of x all over h. So that's going to be our 4h minus 2xh minus h squared all over h. Now what we need to do is factor out an h again. So that way we can cancel that denominator. I'm going to go ahead and go this way. So we're going to get an h factored out. That'll leave us with 4 minus 2x minus h all over h. And our h's again will cancel. And we are left with 4 minus 2x minus h. All right. Last step is to find the limit part. So we are now looking at f prime of x, which is equal to the limit as h approaches 0 of our f of x plus h minus our f of x all over h. So we are looking at this will be equal to, for us, the limit as h is approaching 0 of our 4 minus 2x minus h. So again, no h, no h, so those will stick. So that'll be 4 minus 2x, and as that h approaches 0, it's going to get really small. And so that will be our final answer. Okay, so our next problem that we are going to, our next thing we're going to look at is some common issues. So these are some graphs. There's common, and if you're in my class, you have the handout. I'll pop it up there so you can see the words. You can pause if you want to write them. I'm going to kind of read them out. So we have some different graphs where f will not be differentiable at a value of a. So first, if it's not continuous, that's where our limits, remember we talked about limits recently, when they're not the same, it will not be differentiable. If you have sharp corners, if you have a vertical tangent at that spot, where we have x is equal to a, we have two types of graphs there. This also looks like it's a sharp corner, and this kind of goes vertical instead of a continuous function cruising along without. So these are where our graphs will not be. A break in the graph, sharp corners, or vertical tangents at those points. All right. So here's the other part of that if you're wanting to look at it. So now we're going to sketch the graph of f and determine where f is non-differentiable. And we are just going to sketch it. We're not going to use any fancy calculators here because you need to know how to do these things. All right, so here is our function. This is example 3. And our function is equal to, it is a piecewise function. So we have x squared if our x is less than 0, and we have 1 if our x is greater than or equal to 0. So let's talk about what this means. If x is less than 0, that's where it's negative. And if we look at a graph, we have these graphs here. If we look at a graph, negative values of x will be on this side of the graph. Positives are going to be on that side. So this will be the left side of the graph and the right side of the graph. So I want to kind of point that out to you so that you're making those connections. So this will be where it's negative, which will tell us this will be the left side. And these are going to be positive, so it will be on the right side of your graph. So when we go looking at things that we can't now, there is an x squared, so we expect with an x squared we would have a vertex. Sometimes some of this is going to be great and happy for you for your graph, and some days or some parts may not be as much, but it kind of gives you an idea. All right, so for the vertex, this is we just have because we have the x squared, we are going to use the negative b over 2a formula, which you would have learned in college algebra. So negative b over 2a. Let's pop in our values. So we already have our green up there, so let's go with the brown. So we just have x squared. So that's going to be, there is no b, right? We don't have like a 4x minus 7 or so 4x squared minus 7. There's no b. So that's going to be 0. Now our a is going to be a 1 because we're looking at ax squared plus bx plus c. So our a will be 1. So you're going to get 0 over 2, which is just 0. And then we need to find the function at that value. So the function at 0, which is the answer we found there, well, that's going to get us 0 squared, which is just 0. So this gives us a point of 0, 0. That would be the vertex. Now, pay attention though, this graph is not defined at 0. But so this is going to be, this part of the graph is not defined at 0. So it will be an open circle. Because we're looking at a positive parabola, that's what we expect is that vertex, but it's going to be an open circle. And because it's at 0, 0 on our graph, this will also be our y-intercepts. The vertex would also be, is the y-intercept, just so you're aware. Even though it's not really going to intercept it because it's not defined there, that is where it would cross it. So we're not going to find the y-intercept, but sometimes that is helpful. So the next thing we want to do is we need to find a couple of points. Now remember, our x is negative for this. So we've got our x, we've got our y. I'm going to pick -1 and I'm going to pick -2 because 2 points will help us graph our graph. So we have, plugging it into our x squared, we have -1 squared, which will get us +1. And then we have -2 squared, which is +4. So that gives us a couple of points because we do have to have our negative values for this part of our graph. All right, the third part of our graph that we're going to do is 1 if x is greater than 0. So that means it's got positive values, right? We don't really have a function so much because we have 1. So let's pop in some x values so that we can figure out what our points are. So if x is 0, our y is still going to be 1. If x is 1, our value is 1. If x is 2, our value is 1. It doesn't matter if positive value is going to get us 1. So basically, that's going to give us a horizontal line at y equals 1. We're looking at a horizontal line there that's coming across because no matter what x is, y will equal to 1. All right, so let's go to part 4. We are going to draw our graph. Nothing fancy smancy. We're just going to sketch it out. We have enough information that we have some x's and some y's. I'm going to put 4 hash marks going up And I'm going to put a couple going this way and this way. Try to make them evenly distributed. Mine clearly are on this side, but not with that side, but it's all good. All right, so let's graph what we know. We know that on the top part, we had an open circle here, and then we had our negative 1, 1 right there, and we have our negative 2, 4 right there. So this part of our graph is going to graph like this. That's the half of the parabola that is defined by our function, by our parameters. The other part of the graph is going to be at y equals 1. I made that point a little bit too low, but that's okay. So it's going to be a closed circle there and go straight out. And there's your graph. So we were able to sketch our graph and determine where f is non-differentiable. So where is it non-differentiable? That is at the 0 because the graph is not continuous. So our function is non-differentiable at x equal to 0 because the graph is not continuous. All right, we have one more problem. Nice part is if you need to catch something again, just stop and back it up. All right, so our next one, I'm going to pull this page. We are looking at finding the indicated quantities for a function. We want to the slope of the secant line, the slope of the graph, and the equation. All right, so this is example 4. So our function is f of x equal to x squared. So the very first thing it asked us for was the slope of the secant line through the points. All right, so we're going to do f of x plus h minus our f of x all over h. And I'm going to write slope of a secant line, so that's not what you know we are doing. All righty. Now, it gave us specifically what to plug in. It said slope of the secant line through the points of 1, f1, and then 1 plus h, f at 1 plus h. And of course, h can't be 0 because then we're dividing by 0. And our h, even though if our limits go towards 0, it doesn't mean h equals 0 on those other problems that we have done. So we are looking at our 2 points. We're looking at f at 1, comma, let's see, let me write this. We've got 1, f at 1, and we also have 1 plus h, f at 1 plus h. Those are the 2 points we're looking for, since you do not necessarily have our handout. All right, so let's go find this part. All righty, we have f at 1 plus h minus f at 1. Those are the 2 values that we are looking at. We have our f of x plus h, f of x. They've kind of told us this is what we're looking for. And this will all be over h. So I'm going to go find these 2 parts. So f at 1 plus h, and I'm going to go find f at 1. So that's going to get us 7 times 1 plus h squared. And this is going to be similar to what we did before. Let me go do a side note over here. Our 1 plus h quantity squared, again, is 1 plus h times 1 plus h. That is going to get us 1 squared plus 2h plus h squared. And of course, 1 squared will become, oops, sorry, you couldn't see, is going to become 1. All right, so that's going to get us 7 times our 1 plus 2h plus h squared. And we've done this on a couple of problems. We did it on 1c and 2c. So this will equal 7 plus 14h plus 7h squared. And again, I made my side note too big. So sorry. And then f at 1, we're going to have 7 times 1. And I think I left off a number up there. I did. So sorry. It's 7x squared. In case you're like, where did the 7 come from? I don't have my students in class asking me. So there is a 7 in front of the x squared. So that's 7 times 1 squared, which will get you 7 times 1, which is 7. So now we can come up here and plug in our values. So we're going to have our 7 plus 14h plus 7h squared minus 7 all over h. Now, 7 minus 7, and I didn't do parentheses on this part because it was just a number. If I was subtracting a whole function, I would have done that. All right, so those are going to cancel. And that will leave us 14h plus 7h squared all over h. And again, like we've done before, we're going to factor out the h. I think I'm going to, I did not, I wrote too big. So sorry. So we have 14h plus 7h squared over h. I don't normally do that, but we're just doing that today. So factor out an h. We have 14 plus 7h all over h. Again, the h's will cancel, and we are left with 14 plus 7h. Now, part B, so that was finding the slope of a secant line. We want to find the slope of the graph at our point right here. So for B, we're looking at the limit as h approaches 0 of our f of x plus h minus our f of x all over h. And so that'll be what we just found. So this will be, let me do it in green. We have the limit as h is approaching 0 of 14 plus 7h. Again, our h is going towards 0, so that is going to cause that just to be 14. And just so you understand, this is the slope of the graph at that point they are asking for of 1 of f at 1. So 14 is our slope. All right, the last part is looking, because that's our rate of change, that's our slope. So the equation of, actually this is the instantaneous rate of change, just to be specific. The equation of the tangent line at this point again. So equation of a line, this is something you would have learned in algebra. So you got y minus y1 equals m times x minus x1. This equation of the tangent line. And we're at that point of 1f at 1. That's what they're giving us again. So we already know some of our parts. So we've got our slope, our m is 14 from part B. And then from part A, we found right up here, we found f at 1 is equal to 7. That gives us a point. We know that f at 1, so this gives us the point of x being 1, we get a y value of 7. So that gives us our slope, and this will be our x1, y1 that we can plug in. All right, so we're going to have y minus our y1 of 7 equals our slope of 14 times x minus our x1, which is 1. All right, let's do our algebra. We've got 14x. 14 times -1 is minus 14. We're going to add that 7 to both sides. We get y is equal to 14x minus 7. That's the equation of the line, of the tangent line.